Right. Right now. You see here, suppose we have a RL circuit, and here we are using the supply. This is, we can say, V, and here we are going to use one switch, switch S, and after that we have a resistance as well as inductance. So this is the circuit diagram. This is RL circuit, and this is at a transient condition what is happening. Transient condition, what will happen, that we will see. This is R and this is L. So when switch is 0, that is, we can call it as a at T is equal to 0. That means the switch is in open condition. Open condition. Switch is in open condition. Right. So whenever the switch is closes, then what happened here at T is equal to 0 plus. The meaning of this is the switch is, when the switch is closes at that time, then you see here. So what will happen here? Inductor L is in open because right. So you see here. So whenever only is there, then immediately the current will be flowing like this. So the current will be flowing like this. If you have only resistance, high current. But here what is happening? We have a inductance. So inductor, it behaves like a sudden changes of current. It will not be allowed through the inductor. What is happening? With the time, slowly the inductor L allows current. How this will be, that I will explain you here. So whenever the switch is open condition at T is equal to 0, switch is in open condition. So at the time switch is open means no current will flow, because when the circuit is in open condition, what is happening? Voltage, the current will not be flowing through the circuit. Whenever the closed path is appears, then only the current will be flowing. Otherwise, current will not be flow. So in this condition, I naught or I is equal to 0. This is the condition. At T is equal to 0, I is equal to 0. And at T is equal to 0 plus, again we have a problem. What is the problem? The inductor will not allow the current, shunt currents, it will not allow through the inductor. So how it will be allows? Slowly it will be allows the current. Slowly. That means from 0 time to, it will allows maximum to infinity. So from t is equal to 0 to t is equal to infinity, the inductor will allow current, full amount of current, full current it will allows. Okay, ma? Are you understand this point? All, all of you must respond. Hello? Okay, okay. Right, dear students, is it visible? The screen not visible?
No, sir.
Okay. Now, ma?
Visible, sir.
Yes, sir.
Right, 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 right. Okay, okay, okay. Thank you. And I want to explain you. Once again, I repeat this one. So, RL circuit, RL transients. I'm going to explain you RL transients. RL transients. Afterwards, we will see the RL transients. First of all, we have to know the what is transient. Okay. So the meaning of transient is nothing but a for understanding. I am going to explain you here. So the meaning of transient is nothing but a the circuit responds to a sudden change in an input that is called as transient. That means if you give the input supply to the circuit, then it will give the sudden response is called it as a transient. For example, we have a switch. Switch is whenever we are not close the switch, then it will be in one state. Once we switched on that one, then immediately current flow through the circuit, and at some time it will be um, settles the value, so that is called it as a transient. That means zero position to settling time is there. No, in between of these two, the is called it as a transient condition. So this transient condition will be appears and available only in a resistance, sorry, inductance and capacitance only, or the combination of resistance and inductance. So that I will explain you here. So here, this is nothing but RL combination, RC combination, RLC combination, RLC combination. So here you see, without resistance also, it will use the transients. But if we have a R, then it will be benefit for us. So without resistance, we cannot get a load. That's what we are going to consider this RL, RC, RLC. So these RL, RC, RC, RLC circuits, input is either it may be a AC excitation or in a DC excitation. So that excitation in the sense is nothing but supply. So for that, I'm going to give you the RL circuit. So here I can draw the RL circuit. So who is there, ma? Yes, Dinesh. Right. So this is the supply, and we are going to use one switch. This is called it as a switch S, and we have a resistance R and inductance L. And here, this is the supply voltage V. So L and C are storage elements. These storage elements will give the sudden changes. If you give the current, then inductor will give sudden changes will not allow through it. If you give the voltage to the capacitor, then sudden changes of voltage it will not be allowed through it. So these are the things which is happening in this inductor and capacitor, so that we can say here RL circuit or RC circuit or RLC circuit or LC circuit. So these are all nothing but a storage elements, combination of resistance and inductance, combination of resistance and capacitance, combination of resistance, inductance, capacitance with a AC or DC. So we are going to study these three, AC or DC. First, we will see the DC. So when we are giving the supply, PS voltage, and switch is open condition, no current will flow. If switch is in open, I naught is I is equal to 0 because it is in an open circuit. And if you close the switch, you are closing the switch, then current will be flowing like this. Okay, this is current flowing. So here I current will be flow. So here I can write here V is equal to, by Kirchhoff voltage law, the algebraic sum of all the voltages within a loop is equal to 0. That means this is nothing but a VR, voltage across resistance is equal to VR, and voltage across inductance is equal to VL. So this is equal to VR plus VL, where VR is equal to, we can say, I into R, plus VL is equal to L di by dt. This is equal to V. Okay, ma? And now we'll see now. I can take this one, di by dt plus di by dt plus R by L I is equal to V by L. So what I'm doing, I'm taking L into outside. So di by dt plus R by L into I is equal to V by L. This is nothing but a first order, first order differential non-homogeneous equation. That means, so if di by dt plus R by L into I is equal to 0, then we can say homogeneous equation, and we don't have a 0, so that it is a non-homogeneous equation. It may comes into your mathematics, first year mathematics, so that it is a first order differential equation. So for this, we have a current response is equal to I is equal to, we can say this is equal to IC plus IP, where IC is equal to we can say that transient current or we can say transient current or complementary function. We can say directly here complementary function. Complementary function, and IP is equal to particular integral. Okay, so I don't want to tell all these things how we are getting this IC and IP. Directly, I can write here. I think all of you know in first year, so that I can write here IC is equal to, we can say IC is equal to P into e to the power of minus R by L into T. See, it's nothing but a di by dt plus R by L into I is equal to V by L. So for this, we have a IC is equal to P into, sorry, this is nothing but V by R. Okay, this is V by L. And IP is equal to particular integral. That is, the meaning of particular integral is whenever the inductor gets saturated, saturated means settled, then we can say it is a particular integral. So when it is settled here, then the current flowing through will be maximum, so that we will have only a resistance. That means the circuit will be like this. Switch, then resistance, then like this. So this is V and this is R and this is equal to I. So whenever it is like that, this is called it as a particular integral. So the particular integral IP is equal to, we can say V by R. V by R. So here I is equal to, so I is equal to, we can say complementary function C into e to the power of minus R by L into T plus P is equal to V by R. So this is the equation. And to find out this equation, So here we know, R we know, R we know, L we know, and time is equal to time, instant time. But we don't know the C, constant value. C is constant. To find C, we are going to use initial condition. Initial conditions. The initial conditions are at t is equal to 0, I is equal to 0. I told you, initially what is happening, switch is the open condition at the time, t is equal to 0, I is equal to 0. So substitute these values into here. So these values into here. Then we will get the answer that is current. That is equal to, I can write I is equal to C into e to the power of minus R by L into T plus V by R. So substitute T, I is equal to 0, that is 0 is equal to C into e to the power of minus R by L into T is equal to 0 into 0. So e to the power of this total value goes to 0. So e to the power of minus 0 is equal to 1. So that 0 is equal to C plus V by R. From this, C is equal to minus V by R. So substitute this value into here, then I is equal to. So dear students, all of you, step by step, you can write here. Then only you can understand, and you go to your home and practice it. And here you see, I is equal to, we already find the C value is equal to minus V by R. So minus V by R e to the power of minus R by L into T plus V by R plus V by R. So this is equal to, we can write here, I is equal to, I can take this V by R common into 1 minus e to the power of minus R by L into T, where R by L is time constant. Say time constant. So this is the I value for this case. And I will explain you here why this is a instant transient value. That I will explain you here. So here you can see, I can draw the circuit graph here. This is time and this is I. So with this, if you put t is equal to 0, then 1 minus this value is equal to 0, u to the power of minus 0 is equal to 1, 1 minus 1 is equal to 0, 0 into v by r, that is 0. So put t is equal to 0, I is equal to 0. I is equal to 0. Okay, then put t is equal to L by R. T is equal to L by R. Then we may have a e to the power of minus 1. So e to the power of minus r by L into L by R. So both will be equal and opposite. So we will get e to the power of minus 1. That value is equal to 0. E to the power of minus 1 is equal to 0.3. That point is equal to, we can say that e to the power of 0.6332. So here, if you substitute that value here, we may get this is equal to I is equal to V by R into 1 minus 0.632, that is equal to 0.38368 V by R. V by R is nothing but I, so that it will be in somewhere. This is equal to, you can consider this is equal to maximum I, and this is nothing but V by R, that is equal to I. So 0.63, so it may be somewhere here. And t is equal to infinity, we will get this one. So I can say, I can write the diagram like this. So this is nothing but a settling time of the inductor. So from 0 to settling time, we can call it as a transient condition. So I is equal to V by R into 1 minus e to the power of minus R by L into T. This is, I think, yes, ma.
Sir, e power minus 1 is 0.367, sir.
0.367. 367. Okay. Yes, so e to the power of minus 1 is equal to 0.367. Right?
Yes.
367. Okay, sorry. So if you put here 0.367, then how much we are getting? 0.632, right? Okay, ma?
Yes, sir.
How much we are getting I value? V by R into
0.63.
This is correct now? So 0.632 V by R. Right, ma?
Yes, sir.
Yes, sir.
Right. Okay. Right.
Yes, sir.
So that is the value of this one. So it maybe appears here. So if you draw the circuit graph between time to current, it may be settled at this portion. This is called it as a infinity time. That means t is equal to infinity means we are getting this value is equal to 0. So V by R into 1 is equal to V by R only. So I is equal to V by R. This is at infinity. At infinity time, it will be a settling time. So from 0 to infinity, we can call it as a transient condition. I told you, whenever we are giving the switching on the switch, then immediately the current will be flowing through it, and the inductor will not allow the sudden changes of current, so that slowly it will be changes. That slowly changes means here current is slowly allowing through the inductor. So once it comes to this portion, then it will allows completely. From here, it will allows completely. So it will be short circuited. So that we may have only resistance. That's what this is called. V by R called it as a particular integral. Okay, right. So this is the I value. Then we know the I value. Then we can find out the voltage across the resistance as well as inductor. That we will see. What is the formula for voltage across resistance? We can say VR is equal to, we can say I current flowing through the resistance into R. That is nothing but IR. So into R. So this is equal to, I is equal to what? V by R into 1 minus e to the power of minus R by L into T. So that I can write here V by R into 1 minus e to the power of minus R by L into T into R. So that this R gets cancelled. So voltage across resistance is equal to V into 1 minus e to the power of minus R by L into T. This is called as a voltage across the resistance. And we will see the voltage across inductance. We can say voltage across inductance is equal to IR. Sorry, VL, that is equal to L di by dt. So this is equal to L into d by dt of I is equal to V by R into 1 minus e to the power of minus R by L into T. This is the current. So now you see this is equal to L into, see, V by R into 1 is equal to V by R only. So that value is constant. Right? That value is constant. So that d by dt of constant, that will be 0. Next, you can go to here. Then we are getting this value is equal to d by dt of minus V by R and e to the power of minus R by L into T1. So this is equal to L into minus V by R and d by dt of e to the power of minus R by L is equal to, we can say, e to the power